One of the biggest mistakes people make when preparing for the TOGAF 10 certification exam is jumping straight into advanced concepts without understanding the framework's foundation, and that can make even simple exam questions confusing. In this complete TOGAF 10 exam prep study guide, we will go through all 6 sections step by step, starting with the core principles of enterprise architecture and the TOGAF standard. You'll learn the key terminology, understand how the framework is organized, and build the foundation you need for more advanced topics and exam questions. I've also included a free study guide with some of the most important questions in the description, so make sure you check it out. And don't skip around if you can avoid it. Watch the complete video because each section builds on what you learned before. Stay with me until the end, because I'll also share a simple strategy that can help you prepare more effectively and make it easier to pass your TOGAF 10 certification exam. Enterprise architecture is a strategic planning discipline that helps organizations align their business vision with their technology infrastructure. Without enterprise architecture, large companies often struggle with fragmented systems, redundant software, and wasted operational budgets. By creating a unified blueprint, enterprise architecture allows business leaders and technology teams to communicate clearly and make smarter decisions. On your exam, remember that enterprise architecture is designed to manage organizational complexity and support continuous business change. The TOGAF standard, developed and maintained by the Open Group, is the world's most widely used enterprise architecture framework. It provides a common vocabulary, proven methods, and recommended practices for designing, planning, implementing, and governing an enterprise architecture. Rather than forcing you to invent architecture processes from scratch, the framework offers a reliable baseline used by major enterprises globally. The exam frequently tests your understanding of why the framework exists and how it standardizes architecture practice. In its 10th edition, the TOGAF standard uses a modular structure divided into 2 main parts, the fundamental content and the series guides. The fundamental content contains the core concepts, definitions, and the architecture development method that apply to every enterprise. The series guides offer specific, practical guidance tailored for topics like security, digital transformation, and cloud architecture. Exam questions often check if you know the difference between universal core principles and domain-specific guidance. To organize complex systems, the TOGAF standard divides architecture into 4 primary domains, often remembered by the acronym BDAT. The first domain is business architecture, which defines the business strategy, governance, organization, and key business processes within the company. It clarifies how an organization operates day-to-day to deliver value to its customers. Exam scenarios usually highlight business architecture as the starting point for aligning technology investments with business goals. The second component of the architecture domains is information systems architecture, which is split into 2 related areas, data architecture and application architecture. Data architecture describes the structure of an organization's logical and physical data assets and data management resources. It focuses on how data is stored, shared, and maintained to ensure accuracy across the enterprise. On the exam, remember that data architecture ensures information flows smoothly to support critical business decisions. The application architecture aspect of information systems architecture defines the individual application systems needed to process data and support the business. It focuses on how software applications interact with each other and with business processes, rather than detailing how individual software programs are coded. Understanding application interactions helps architects eliminate redundant software platforms across the company. The exam will test your ability to distinguish between application interaction models and underlying technology hardware. The fourth architecture domain is technology architecture, which outlines the software and hardware infrastructure required to support application and data services. This includes networks, servers, cloud infrastructure, storage systems, and operating software that keep applications running smoothly. Technology architecture provides the physical and logical foundation upon which all other enterprise systems operate. Exam questions often test how technology infrastructure choices directly enable or constrain upper-level business processes. A fundamental concept in the TOGAF standard is the definition of an enterprise itself, which can mean much more than just a single company. An enterprise can refer to a whole corporation, a single division, a government agency, or even a network of partner organizations working together. The boundary of the enterprise depends entirely on the scope of the architecture project being undertaken. On the exam, pay close attention to scenario details, as defining the enterprise scope correctly is always the first step. Architects must understand three key state descriptions: the baseline architecture, the target architecture, and transition architectures. The baseline architecture represents the current state of the organization before any changes are made. The target architecture represents the desired future state that fulfills the business goals and strategy. Transition architectures are intermediate states that show progress step by step toward the target state over time. When building architectures, architects work with deliverables and artifacts, which are distinct types of architectural work products. A deliverable is a formally specified, contractually agreed output that is reviewed, agreed upon, and signed off by stakeholders. An artifact is a smaller, fine-grained piece of architectural content, such as a diagram, matrix, or report, used to create views of the system. The exam frequently tests your capability to categorize work products correctly as either deliverables or supporting artifacts. Another critical architectural concept is the building block, which is a reusable component of business, or architectural capability. The TOGAF standard divides building blocks into architecture building blocks, which define what capabilities are needed, and solution building blocks, which define how those capabilities are actually implemented using real products or components. For exam success, remember that architecture building blocks represent requirements and functions, while solution building blocks represent specific hardware, software, or vendors. Stakeholders are individuals or groups who have key interests or concerns in the outcome of an enterprise architecture project. Stakeholders can include executive leaders, department managers, IT developers, security teams, and end users. Identifying stakeholders early is essential because their needs drive the direction and goals of the entire architecture initiative. Exam questions often ask how architects capture, prioritize, and manage stakeholder expectations across the architecture lifecycle. To address stakeholder concerns effectively, architects use concepts called views and viewpoints. A view is what a specific stakeholder actually sees when looking at an architecture, tailored to show information relevant to their needs. A viewpoint is the template, schema, or set of rules used to construct that specific view for a stakeholder group. The exam often presents scenarios where you must select the correct viewpoint to address a specific stakeholder concern. The core operational engine of the TOGAF standard is the architecture development method, widely known as the Admiral. The Admiral is a step-by-step, iterative process for developing, implementing, and managing enterprise architecture. It consists of multiple phases arranged in a cycle that guides architects from initial planning through implementation and ongoing change management. You will see numerous exam questions asking about the sequence, purpose, and key activities of the Admiral phases. The enterprise continuum is a conceptual framework that helps architects categorize and store architecture assets, models, and patterns. It acts as a mental model for moving from broad, industry-generic architectures to highly specific, organization-tailored solutions. By using the enterprise continuum, architects can leverage existing solutions and best practices instead of reinventing solutions for common enterprise problems. The exam will test your understanding of how assets flow from generic categories to customized implementations. Architecture governance is the practice of monitoring, controlling, and directing enterprise architecture work to ensure it complies with business strategies and organizational policies. Good governance ensures that projects actually build systems according to the approved target architecture rather than taking unauthorized shortcuts. Without effective governance, enterprise architecture initiatives risk losing alignment with long-term business goals. The exam emphasizes governance as the primary mechanism for maintaining quality, accountability, and strategy alignment. A common mistake made by certification candidates is assuming that the TOGAF standard must be followed as a rigid, inflexible rulebook. In reality, the framework is designed to be adapted, customized, and tailored to fit the specific culture, scale, and needs of any enterprise. Architects routinely modify Admiral phases, templates, and terminology to match their organizational environment. Exam questions will test whether you recognize when and how to adapt the framework appropriately. When preparing for fundamental exam questions, focus on understanding the core relationships between business goals, architecture domains, and stakeholder views. Try to visualize how abstract concepts, like building blocks and deliverables, connect to real-world IT and business project decisions. Memorizing definitions is helpful, but applying concepts to realistic scenarios is what will truly ensure high marks on your exam day. Keep this big picture perspective in mind as you progress through each module of this course. Congratulations on completing Section 1 of the TOGAF 10 exam prep course. You have taken a major step forward in building your enterprise architecture knowledge and mastering foundational concepts. To solidify what you have learned and test your understanding, please make sure to complete the attached practice test included with this lesson. Taking practice questions right now will sharpen your active recall, boost your retention, and give you immediate confidence for exam day. Keep up the momentum, and I will see you in Section 2 where we explore the architecture development method phases. Welcome back to Section 2, where we dive straight into the heart of the TOGAF framework, known as the Architecture Development Method, or ADMIRAL. In this lesson, you will learn the exact sequence, objectives, and key deliverables of every phase in the ADMIRAL cycle, from initial preparation all the way through ongoing change management. Mastering these phases is essential because ADMIRAL questions make up a massive portion of your certification exam and define how professional enterprise architects work every day. Get ready to master the step-by-step process that transforms complex business strategies into fully realized technology solutions. The architecture development method is structured as a continuous circle of phases surrounding a central core called requirements management. The methodology is designed to be iterative, meaning architects do not simply run through the phases once and stop, but rather loop through phases as needed at different levels of the organization. On your exam, remember that iteration can happen within a single phase, across multiple phases, or across entire architecture projects. Understanding this flexible, circular structure helps you see how architecture adapts dynamically over time. The journey begins with the preliminary phase, which sets up the enterprise architecture capability within an organization before any specific architecture project is launched. In this phase, leaders define where within the enterprise the architecture work will take place, who will do the work, and how it will be conducted. The primary objective is to establish an operational architecture capability that has executive support, defined organizational roles, and appropriate tools. Exam questions often highlight the preliminary phase as the phase where the framework itself is tailored. A key activity in the preliminary phase is establishing architecture governance, including the creation of an architecture board and architecture principles. Architects define the governance framework, select architecture tools, and customize the TOGAF process to align with company culture and existing frameworks like ITIL or COBIT. The major deliverable created here is the organizational model for enterprise architecture, which defines roles, responsibilities, and decision-making authority. On the exam, remember that if a question asks about configuring the architecture team or setting up governance rules before starting a project, the answer points to the preliminary phase. Once the architecture framework is established, the team moves into Phase A, titled Architecture Vision. The main purpose of Phase A is to gain high-level executive approval and define the scope and boundaries of the specific architecture initiative. Architects work closely with business leaders to identify core goals, strategic drivers, and critical success factors driving the change. The primary deliverable produced in Phase A is the Statement of Architecture Work, which serves as a formal contract between the architecture team and business sponsors. During Phase A, architects also create the Architecture Vision document, which presents an easy-to-understand summary of the current problem and the proposed target solution. To ensure all relevant needs are captured, Phase A involves identifying key stakeholders, analyzing their concerns, and creating a stakeholder map. Architects use business scenarios to highlight how the proposed architecture will solve real business problems and deliver measurable ROI. On the exam, remember that Phase A secures management buy-in and establishes the official scope before detailed design work begins. After securing approval in Phase A, the team advances to Phase B, which is business architecture. Phase B focuses on describing the baseline business state and designing the target business architecture that supports the company vision. Architects document business strategy, organization structures, business capabilities, and core business processes. By mapping out how business operations function, this phase ensures that all technical decisions made later directly serve concrete business needs. A central technique used in Phase B is gap analysis, where architects compare the baseline business architecture against the target business architecture to discover what is missing, redundant, or needs modification. The deliverables generated in Phase B include detailed business models, capability maps, and updated sections of the architecture definition document. On the exam, remember that Phase B is crucial because technical architecture can only succeed if it rests on a clear, well-structured business foundation. Phase C is named Information Systems Architectures, and it is divided into two distinct subdomains that can be addressed in either order: data architecture and application architecture. The purpose of Phase C is to define how data and application systems support the business architecture established in the previous phase. Combining data and software systems into one phase ensures that information flows cleanly to the applications that process it. Exam questions frequently test whether you know that Phase C addresses both data structures and application interactions. The data architecture portion of Phase C defines the logical and physical data assets of the enterprise, along with data management resources. Architects analyze how data is created, stored, transformed, and consumed across various business functions. The goal is to eliminate data silos, improve data quality, and ensure data security across the entire enterprise. On the exam, focus on how data architecture creates a unified information structure that allows systems to communicate reliably. The application architecture portion of Phase C defines the major kinds of application systems needed to process data and support business capabilities. Rather than designing individual software code, architects focus on system functions, application boundaries, and integration interfaces between systems. This prevents redundant software purchases and ensures applications interact smoothly across departments. Exam questions often ask you to distinguish between managing software code versus defining application system boundaries and interrelationships. Next comes Phase D, which is technology architecture, focusing on the underlying infrastructure needed to host applications and manage data. Phase D defines the baseline and target technology architectures, including servers, operating systems, cloud environments, networking components, and storage systems. Architects select hardware platforms, network topologies, and middleware that provide the performance, security, and reliability required by upper-level systems. On your exam, Phase D represents the physical and logical IT infrastructure underpinning the entire solution. During Phase D, architects conduct a thorough technology gap analysis to identify hardware upgrades, infrastructure migrations, or cloud adoptions necessary for the target state. The key outputs include the technology portion of the architecture definition document and the architecture requirements specification. Understanding Phase D helps you answer exam questions regarding technical feasibility, infrastructure constraints, and hardware lifecycle management. Phase E is titled Opportunities and Solutions, marking a major shift in the Admiral from architecture design to implementation planning. In Phase E, architects review the gaps identified across Phases B, C, and D, and group them into logical work packages. The primary objective is to evaluate implementation options, identify major transition architectures, and outline an initial strategy for delivering the target architecture. Exam questions frequently test Phase E as the step where solution building blocks are selected and initial project ideas take shape. Phase F moves into migration planning, where the team creates a fully detailed, prioritized implementation and migration plan. Architects work alongside project managers, financial planners, and business leaders to perform cost-benefit analyses and risk assessments for each work package. Phase F establishes explicit timelines, resource allocations, and dependencies to guide project teams during rollout. On the exam, remember that while Phase E outlines potential solutions, Phase F creates the final, realistic execution roadmap. Phase G is implementation governance, where the architecture team shifts into an oversight role during actual software development and deployment. The goal of Phase G is to ensure that implementation projects conform fully to the approved target architecture and statement of work. Architects perform compliance reviews, issue architecture contracts, and provide technical guidance when developers encounter unexpected build challenges. The exam emphasizes Phase G as the guardian phase that prevents projects from straying away from architectural standards. Phase H is architecture change management, which establishes procedures to monitor changes in technology, business goals, or external regulations after deployment. Phase H evaluates incoming change requests to determine whether a minor update is sufficient or if a brand new ADM cycle must be initiated. This continuous monitoring ensures that the enterprise architecture remains living, adaptable, and aligned with evolving business strategy. Exam scenarios often ask how architects handle continuous change requests after project delivery. Operating continuously at the center of all Admiral phases is requirements management, which acts as the dynamic hub for capturing and validating requirements throughout the architecture lifecycle. Requirements management does not belong to a single phase, but rather interfaces with every phase from preliminary through Phase H. Whenever new business needs or technical constraints emerge, they are recorded and processed through this central mechanism. On the exam, remember that requirements management ensures architectural decisions always reflect validated stakeholder needs. A common mistake candidates make on the exam is confusing the key responsibilities of Phase E and Phase F. Always remember that Phase E focuses on identifying potential implementation options and defining transition steps, while Phase F focuses on detailed project planning, resource budgeting, and finalizing the migration roadmap. Additionally, keep in mind that Admiral phases can overlap, run in parallel, or iterate based on project demands. Keeping these distinctions clear will help you answer complex scenario questions with complete confidence. Congratulations on completing Section 2 of our TOGAF 10 exam prep course. You now have a comprehensive understanding of the architecture development method phases, their objectives, and how they flow together seamlessly. To ensure these concepts stick, please complete the practice test included directly with this lesson. Working through practice questions will test your recall of phase deliverables, sharpen your exam skills, and significantly improve your readiness. Keep up the great work, and prepare yourself for Section 3, where we will master Admiral guidelines and essential architecture techniques. Welcome back to Section 3, where we explore the essential Admiral guidelines and techniques that make enterprise architecture work in practice. In this lesson, you will learn how to apply key techniques like architecture principles, gap analysis, business scenarios, and risk management across the Admiral cycle. These practical tools bridge the gap between theoretical methodology and real-world implementation, making them heavily tested topics on the certification exam. Get ready to enhance your analytical toolkit with the exact techniques that expert architects rely on every single day. Before exploring specific tools, it is important to understand the distinction between ADM guidelines and Admiral techniques. Guidelines explain how to adapt the Admiral process to accommodate different organizational contexts, architectural styles, or iteration cycles. Techniques provide specific, step-by-step methods used to accomplish tasks within individual Admiral phases. The exam frequently tests your understanding of how guidelines modify the overall flow of the framework, while techniques help you produce specific architectural outputs. Architecture principles are enduring, high-level rules and guidelines that inform and support how an organization fulfills its business mission. Principles are established during the preliminary phase and apply across the entire enterprise to guide all technology and business decisions. Because principles are intended to be long-lasting, they are rarely amended once approved by business leadership. On your exam, remember that architecture principles serve as the ultimate criteria for evaluating competing design options. To ensure clarity and enforceability, every architecture principle must follow a standardized structure consisting of 4 key elements: name, statement, rationale, and implications. The name should be clear and easy to remember, while the statement explicitly defines the rule in unambiguous terms. The rationale explains the business benefits and justification behind the rule, and the implications outline the practical operational and financial impacts of adhering to it. The exam frequently asks candidates to identify these 4 mandatory components. High-quality architecture principles must satisfy 5 core criteria. They must be understandable, robust, complete, consistent, and stable. Understandable means the wording is clear to non-technical business leaders, while robust means the principle is strong enough to support definitive decision-making. Consistency ensures that principles do not contradict each other, and stability means they do not change frequently. Recognizing these quality criteria will help you evaluate sample principles in scenario-based exam questions. Another fundamental technique is the business scenario, which is used primarily during Phase A and Phase B to uncover and validate business requirements. A business scenario is a structured method for gathering information about business goals, user needs, and operational pain points. It creates a complete story that links business problem drivers directly to concrete architectural requirements. On the exam, remember that business scenarios bridge the communication gap between business managers and technical architects. A business scenario documents 5 essential elements: the business environment, the specific problem, the human and computing actors involved, the desired business outcome, and the technical requirements. By clearly mapping out these components, architects ensure that proposed technical projects solve actual business challenges. Using business scenarios prevents architecture teams from designing complex technical systems that fail to deliver real business value. The exam often highlights business scenarios as the best technique for establishing early project scope. Gap analysis is one of the most critical and frequently tested techniques in the entire TOGAF standard, applied primarily during phases B, C, and D. Gap analysis systematically compares the baseline architecture state with the target architecture state to identify missing, modified, or newly required components. By carefully highlighting gaps, architects ensure that no critical functionality or system dependency is accidentally forgotten during design. Architects perform gap analysis using a structured gap analysis matrix, placing baseline architecture building blocks along one axis and target architecture building blocks along the other. Items that match indicate components that will be retained, while unmatched items reveal components to be eliminated, newly created, or intentionally upgraded. The exam frequently presents matrix scenarios and tests your ability to identify intentional omissions, new requirements, and unmapped legacy systems. Interoperability is the ability of two or more systems or components to exchange information and use the information that has been exchanged effectively. Defining interoperability requirements is essential when integrating diverse business units, legacy applications, and third-party cloud services. Architects evaluate interoperability early in the Admiral to ensure that technical integration issues do not block business operations later. The exam will test your understanding of how interoperability spans business, data, application, and technology domains. The TOGAF standard categorizes interoperability into distinct levels, ranging from operational interoperability down to technical interoperability. Operational interoperability focuses on alignment between business processes and organizational cultures, while technical interoperability focuses on software interfaces, data formats, and communication protocols. Understanding that true interoperability requires both business alignment and technical compatibility is a key concept for answering exam scenarios. Business Transformation Readiness Assessment is a technique used to determine an organization's willingness and ability to undergo major architectural change. This assessment evaluates factors such as corporate culture, leadership commitment, governance maturity, and resource availability. Conducting this assessment early helps architects identify non-technical hurdles that could cause project delays or implementation failures. Introduced during Phase A and refined in Phase E, the Business Transformation Readiness Assessment produces a clear evaluation of organizational risks and transformation capacity. If an organization lacks readiness in key areas, architects must incorporate specific training, change management, or cultural alignment projects into the migration plan. On the exam, remember that technical perfection alone does not guarantee project success if the organization is unready for change. Architecture risk management is a continuous discipline used to identify, evaluate, and mitigate risks associated with enterprise architecture projects. Risks can stem from emerging technologies, financial constraints, vendor lock-in, or resistance to organizational change. Architects systematically assess risks during Phase A, Phase E, and Phase F to protect the enterprise from costly failures. In TOGAF risk management, risks are categorized as either initial risks or residual risks. Initial risks represent the inherent level of risk identified before any protective actions or mitigations are implemented. Residual risks are the remaining risks that exist after mitigation strategies and safeguards have been applied. Exam questions frequently check whether you understand that residual risks must be formally accepted by business sponsors before proceeding with implementation. Capability-based planning is a business-centric planning technique that focuses on capabilities rather than isolated IT systems or departmental silos. A business capability represents the capacity for an organization to achieve a specific business outcome, combining people, processes, information, and technology. Capability-based planning aligns enterprise architecture investments directly with strategic business objectives. By assessing current versus required capability levels, architects can identify capability gaps and group related improvements into logical work packages. This technique ensures that transformation projects focus on delivering measurable business capabilities rather than simply upgrading technology for its own sake. On the exam, capability-based planning is presented as the primary driver for prioritizing implementation projects in Phase E and Phase F. Tailoring the Admiral is the process of customizing the framework's phases, artifacts, and terminology to fit the specific culture, scale, and needs of an organization. Tailoring takes place during the preliminary phase and allows architects to integrate TOGAF with other methodologies, such as Agile, DevOps, or ITIL. Exam questions will emphasize that tailoring is a mandatory step, as no framework should be applied blindly without local adaptation. A common mistake made by certification candidates is treating architecture principles as optional recommendations rather than binding governance rules. Another frequent error is confusing initial risk with residual risk during migration planning. Paying close attention to these specific definitions and maintaining a clear understanding of when each technique is applied within the Admiral will ensure you score high marks on technique-focused exam questions. Congratulations on completing Section 3 of our TOGAF 10 exam prep course. You have successfully mastered the key Admiral guidelines and techniques that bring architectural rigor to real-world projects. To solidify these concepts and test your understanding, please complete the attached practice test included with this lesson. Practicing scenario-based questions right now will sharpen your analytical skills, improve your exam recall, and build your confidence for test day. Keep up the momentum, and I will see you in Section 4, where we will explore the enterprise continuum and architecture repository. Welcome back to Section 4, where we shift our focus to organizing and reusing architecture assets through the enterprise continuum and architecture repository. In this lesson, you will learn how architectures are classified, stored, and shared across the entire enterprise to maximize efficiency. Understanding these concepts is vital because it prevents your team from constantly reinventing the wheel and wasting valuable resources on problems that have already been solved. Get ready to explore the filing system of the TOGAF framework, which will give you a major advantage on your certification exam and in your future career. The enterprise continuum is a conceptual model used to classify architecture and solution assets as they evolve from generic industry patterns to highly specific organizational solutions. It is not a physical database or a software tool, but rather a mental framework for organizing how you think about reusable architectural components. By classifying assets correctly, architects can easily find and adapt existing models instead of starting every new project from a blank slate. On your exam, remember that the enterprise continuum is all about classifying assets to promote reuse and efficiency. The enterprise continuum is divided into two distinct but related continuums known as the architecture continuum and the solutions continuum. The architecture continuum organizes logical rules, models, and specifications, which essentially describe what needs to be built and how it should behave. The solutions continuum organizes the actual physical products, vendor systems, and software components that are used to implement the architecture. For the exam, keep in mind that the architecture continuum handles the design requirements, while the solutions continuum handles the real-world products that fulfill those requirements. The architecture continuum consists of 4 specific states of architecture, progressing from the most generic to the most specific. The first state is the foundation architecture, which includes highly generic, fundamental concepts that apply to any IT system in the world, regardless of the industry. The TOGAF technical reference model is a perfect example of a foundation architecture because it provides universal building blocks for computing platforms. On the exam, foundation architectures are identified as the fundamental starting point that contains no company-specific information. The second state is the common systems architecture, which contains architecture models that are useful across many different types of businesses but are not completely universal. Examples include security architectures, network management architectures, and email routing systems, which operate similarly whether you are a bank or a hospital. These systems provide common infrastructure services that support a wide variety of business applications. Understanding this level helps you answer exam questions about sharing baseline infrastructure patterns across different enterprise divisions. The third state is the industry architecture, which contains models and patterns specifically designed for a particular business sector. For instance, a healthcare organization might use specialized architectural patterns for processing patient records, while a bank would use specific patterns for financial transactions. These architectures incorporate industry standards and regulations, making them highly valuable but only within their specific market. The exam often tests your ability to identify industry architectures by looking for clues related to specific business domains like retail or telecommunications. The fourth and final state is the organization-specific architecture, which represents the most customized and tailored level of the continuum. This contains architectures that are entirely unique to your specific company, incorporating your exact business processes, internal policies, and strategic goals. This level provides the highest business value to your enterprise, but has the lowest potential for reuse by outside organizations. Exam questions will expect you to recognize that organization-specific architecture is the ultimate destination for assets flowing through the continuum. Running parallel to the architecture continuum is the solutions continuum, which also follows a 4-step progression from generic to specific. While the architecture side deals with designs and rules, the solutions side deals with the physical products, systems, and vendor software purchased to build the environment. Whenever a generic architecture requires a specific software product, that product is classified within the solutions continuum. The exam frequently checks if you understand this parallel relationship between abstract designs and concrete implementations. The first level of the solutions continuum is foundation solutions, which are highly generic technology products that provide basic computing functions. These include standard operating systems, generic database engines, and basic network hardware that any company could purchase off the shelf. These products have not yet been configured to perform any specific business task, making them universally applicable. On the exam, remember that foundation solutions are raw, unconfigured technologies used to build more complex systems. The second level is common system solutions, which are products designed to provide shared services across an organization. A great example would be an enterprise identity management system or a standardized corporate email platform. These products provide essential services that multiple different departments and applications can rely upon simultaneously. Exam scenarios often describe these as enterprise-wide software products that reduce duplication of basic IT functions. The third level involves industry solutions, which are specialized software products built explicitly for a single industry sector. A retail point-of-sale system, an airline reservation platform, or a hospital patient management system all fit into this category. These solutions come pre-configured with industry-specific terminology, regulations, and workflows built directly into the software. The exam will test your ability to match industry-specific software requirements to this exact level of the continuum. The final level is organization-specific solutions, representing the highly customized, fully configured IT systems running inside your specific company. This represents a product that has been fully integrated into your environment, customized with your branding, and loaded with your proprietary data. It is the real-world deployment that fulfills the exact needs of your organization-specific architecture. Exam questions will ask you to identify this level as the final, fully implemented state of a technology project. While the enterprise continuum is a conceptual classification model, the architecture repository is the actual physical or logical storage system where all architectural assets are kept. It acts as a centralized database, file system, or toolset that securely stores all the deliverables, diagrams, and building blocks produced during the admiral phases. Using a central repository ensures that multiple architecture teams across a large organization can share and collaborate on the same up-to-date documents. On your exam, remember that the repository is the practical storage engine that makes enterprise architecture manageable. The architecture repository is organized into several specific classes of information to keep data structured and accessible. One of these classes is the architecture metamodel, which describes the organizationally tailored application of an architecture framework, including its method for architecture development and a metamodel for architecture content. Essentially, it stores the rules and structures defining how your specific company writes and formats its architecture documents. Exam questions often ask where the customized rules for your architecture practice are stored, pointing directly to the metamodel. Another critical section of the repository is the architecture capability, which stores the parameters, structures, and processes that support governance of the architecture practice. This section holds the terms of reference for the architecture board, the architecture principles, and the templates used for compliance reviews. It defines how the architecture team operates, who has decision-making authority, and what standards must be followed. The exam will test your understanding that governance documentation lives within the architecture capability section. The architecture landscape is the section of the repository that stores an architectural view of the building blocks currently in use by the enterprise today. It provides a complete map of the baseline architecture, showing the real business processes, applications, and technology infrastructure currently operating across the company. The landscape is often divided into strategic, segment, and capability architectures to manage complexity. On the exam, remember that the landscape is your primary source of truth for understanding what currently exists in the enterprise. The Standards Information Base is a repository section that captures the exact technical standards, business rules, and legal regulations that new architectures must comply with. This might include international data privacy laws, industry security standards, or internal corporate coding policies. Whenever architects design a new system, they must check the Standards Information Base to ensure their designs do not violate any mandatory rules. Exam scenarios often feature the Standards Information Base as the tool used to audit new projects for compliance. The reference library provides a space within the repository to store guidelines, templates, and patterns that architects can use to accelerate their work. Unlike the Standards Information Base, which contains mandatory rules, the reference library contains highly recommended best practices and reusable reference architectures. This is where architects look for inspiration and proven solutions from previous successful projects. The exam often asks you to distinguish between the mandatory rules of the standards base and the optional best practices found in the reference library. A common mistake candidates make on the exam is confusing the enterprise continuum with the architecture repository. Remember that the enterprise continuum is simply a conceptual classification scheme used to organize your thoughts and categorize assets from generic to specific. The architecture repository, on the other hand, is the actual physical database or tool where the documents, models, and standards are permanently stored. Keeping this distinction clear will help you easily navigate trick questions regarding asset management and storage. Congratulations on completing Section 4 of our TOGAF 10 exam prep course. You now understand how to classify, store, and reuse enterprise assets using the enterprise continuum and the architecture repository. To lock in these crucial concepts, please complete the practice test included with this lesson. Answering these practice questions will dramatically improve your retention, highlight any knowledge gaps, and ensure you are completely exam ready. Keep up your fantastic progress through the course, and I will see you in Section 5 where we unpack the architecture content framework and metamodel. Welcome back to Section 5, where we transition from the processes of the Admiral into the concrete outputs of the architecture content framework and metamodel. In this lesson, you will learn exactly how architecture information is structured, documented, and presented to different stakeholders. Understanding these documentation standards is vital because the certification exam tests your ability to translate abstract architecture phases into tangible business deliverables. Get ready to master the exact terminology and structural models that professional architects use to ensure clear, standardized communication across complex enterprise projects. The architecture content framework provides a structural model for architectural information, ensuring that every project uses the same language and formatting. Without a standardized framework, different architecture teams within the same company might document their designs using entirely different terms and diagrams. This inconsistency creates massive confusion when trying to integrate systems across various departments. On your exam, remember that the content framework ensures all architectural outputs are uniform, predictable, and easy for business stakeholders to understand. To organize this information, the TOGAF standard divides architectural content into three distinct categories known as deliverables, artifacts, and building blocks. Deliverables act as the large folders or formal reports that are signed off by business leaders. Artifacts are the specific documents, like charts or lists, contained within those folders. Building blocks are the individual pieces of data or components that make up the content of the artifacts. Understanding this hierarchy of information is essential for answering questions about how architecture data is assembled and reviewed. Deliverables are the formal, contractually agreed outputs of an enterprise architecture project that require official stakeholder approval. Examples include the architecture vision document, the statement of architecture work, and the architecture definition document. Once a deliverable is signed off, it is securely stored in the architecture repository as an official record of the project decisions. The exam frequently asks you to identify deliverables as the highest level of architectural documentation that drives project funding and formal governance. Artifacts are the smaller, highly focused views of architecture that are created to address the concerns of specific stakeholder groups. Unlike a massive text document, an artifact presents information visually or structurally so it can be easily digested. An artifact could be a financial spreadsheet for a CFO, a network diagram for an IT manager, or a process flowchart for a business analyst. On the exam, remember that multiple artifacts are bundled together to create a single, comprehensive deliverable. The TOGAF content framework classifies all artifacts into three specific types, which are catalogs, matrices, and diagrams. Catalogs are simple lists of building blocks, such as a list of all software applications currently owned by the company. Matrices show the relationships between two different lists, such as a grid showing which software applications support which business processes. Diagrams are visual representations that show complex, multi-directional relationships using boxes, shapes, and connecting lines. The exam heavily tests your ability to choose the correct artifact type based on the specific information a stakeholder needs to see. Building blocks are the fundamental, reusable components of business capability or technology that make up the architectural design. They represent the actual real-world elements you are analyzing, such as a specific customer database, a billing process, or a cloud server. Architects arrange and connect these building blocks within their artifacts to design the target system. On your exam, keep in mind that building blocks are the smallest functional units of the architecture that can be reused across different enterprise projects. To ensure that everyone uses the same building blocks in the same way, the TOGAF standard provides the architecture content metamodel. The metamodel is essentially a blueprint for the architecture itself, defining all the acceptable building block types and how they are allowed to connect. It acts as a strict dictionary and grammar guide for enterprise architects, ensuring a standardized vocabulary. Exam questions often ask you to define the metamodel as the rule set that dictates how architectural elements are classified and related to one another. The content metamodel is deliberately divided into a core metamodel and various metamodel extensions. The core metamodel contains only the most fundamental concepts that every single enterprise architecture project will need, such as business roles, applications, and basic data entities. Metamodel extensions provide additional, specialized building blocks for specific deep dive topics, such as process modeling, data modeling, or infrastructure consolidation. This modular approach allows architecture teams to keep their models simple for small projects, while adding complexity only when specifically needed. Understanding how the content framework maps to the Admiral phases is a major key to passing your certification exam. During Phase A, which focuses on vision and scope, the primary deliverable produced is the architecture vision, which contains high-level artifacts. These artifacts usually include basic stakeholder catalogs and value chain diagrams that show executive leadership exactly what the project intends to achieve. On the exam, connect Phase A to simplified, high-level content designed purely to secure initial project funding and approval. As the team moves into Phase B for business architecture, the metamodel entities become focused on organizational structure and operations. Architects generate catalogs listing all business actors, roles, and functions within the scope of the project. They create matrices to map these business roles against specific business capabilities, identifying exactly who does what within the company. Exam scenarios frequently highlight Phase B artifacts as the crucial link between human employees and the strategic goals of the enterprise. In Phase C, the focus shifts to information systems, requiring content that describes data structures and software applications. For data architecture, architects use the metamodel to define logical data entities, creating diagrams that show how information flows across the corporate network. For application architecture, the content framework provides templates for cataloging existing software and mapping those applications to the business processes they support. On your exam, remember that Phase C artifacts must clearly prove that every software application justifies its cost by supporting a specific business function. During Phase D, the content framework focuses heavily on the physical and logical infrastructure components found in the technology architecture. The metamodel guides architects in documenting hardware nodes, operating systems, network topologies, and cloud hosting environments. The primary artifacts here are detailed technical diagrams that help system engineers understand exactly how to build and configure the target data centers. Exam questions often test your knowledge of how Phase D diagrams provide the physical foundation for the applications defined in Phase C. The most important deliverable generated across these design phases is the architecture definition document. This massive, comprehensive document serves as the primary container for all the catalogs, matrices, and diagrams created during Phases B, C, and D. It represents the qualitative description of the target architecture, explaining what the system looks like and how its components interact. The exam frequently targets the architecture definition document as the ultimate source of truth for the project's design and structure. Alongside the architecture definition document, architects also produce the architecture requirements specification. While the definition document shows what the architecture looks like qualitatively, the requirements specification contains the strict, quantitative metrics the system must achieve. This includes exact performance targets, security compliance rules, data retention limits, and minimum uptime percentages. Understanding the difference between the qualitative design document and the quantitative requirements specification is essential for multiple exam questions. Once the design phases conclude, Phase E uses the content framework to document the transition from current state to future state. Architects generate the implementation factor catalog, which lists all the major constraints, risks, and dependencies that will impact the rollout. They also create a consolidated gap analysis matrix that summarizes all the missing components identified in the earlier phases. On the exam, remember that Phase E artifacts are used to group technical designs into logical work packages for the project managers. In Phase F, the primary output of the content framework is the architecture implementation and migration plan. This deliverable translates all the technical work packages into a formal project schedule, complete with timelines, budgets, and resource allocations. It acts as the bridge between the architecture team and the actual software development and construction teams. Exam questions often check if you know that the migration plan is the final authoritative schedule used to govern the physical build process. When dealing with content framework exam questions, candidates often make the mistake of confusing deliverables with artifacts. Always remember that deliverables are the large, formal documents that require executive signatures, while artifacts are the individual charts and lists inside them. Another common error is forgetting the difference between the three artifact types, so keep in mind that catalogs are lists, matrices are grids, and diagrams are pictures. These simple mental associations will help you quickly eliminate incorrect options on multiple choice questions. As you review this section, practice visualizing the flow of information as it builds up throughout a project lifecycle. Imagine starting with a simple list of business problems in Phase A, expanding that into detailed software catalogs in Phase C, and finally packaging it all into the signed architecture definition document. Seeing how the metamodel connects these pieces prevents the framework from feeling like a random collection of terms and transforms it into a logical, unified system. Keep this structural perspective in mind as we prepare for the final topics of the course. Congratulations on completing Section 5 of the TOGAF 10 exam prep course. You now have a firm grasp of the architecture content framework, the metamodel, and how to structure project deliverables accurately. To reinforce this vital information, please take a few moments to complete the practice test attached to this lesson. Working through these specific practice questions will lock in your understanding of catalogs, matrices, and diagrams, making you significantly faster and more accurate on exam day. Maintain your excellent focus, and I will see you in our final lesson, Section 6, covering architecture capability and governance. Welcome to the sixth and final section of your TOGAF 10 certification course, where we explore the architecture capability framework and governance. In this lesson, you will learn how to establish, operate, and govern a successful enterprise architecture practice within any organization. Understanding governance is crucial because even the most brilliant architectural designs are useless if projects ignore them during implementation. Get ready to master the rules, boards, and compliance checks that give architecture its real power, providing the final puzzle pieces you need to conquer your exam. To understand this section, you must first think of the enterprise architecture practice as a specialized business running inside the larger company. The architecture capability framework provides a set of guidelines for setting up this internal business, ensuring it has the right people, processes, and tools to succeed. Instead of just creating drawings, the capability framework focuses on operational readiness and team structure. On the exam, remember that establishing this capability is the primary objective of the preliminary phase before any actual architecture projects begin. The most important governing body within this capability is the Architecture Board, which acts as the supreme decision-making authority for architecture standards. The board is typically composed of cross-functional executives, lead architects, and key business sponsors from across the enterprise. Its purpose is to ensure that all IT and business projects align with the approved architecture principles and long-term strategic goals. Exam questions frequently feature the Architecture Board as the final escalation point when project managers and architects disagree on a design choice. The responsibilities of the Architecture Board extend far beyond simply attending meetings and reviewing documents. They are actively responsible for enforcing architecture compliance, approving new architecture principles, and resolving disputes when projects request exemptions from the rules. They also identify areas where the baseline architecture needs to be updated to support new business strategies. For your exam, you must recognize the board as the active guardian of the architecture, holding the power to halt projects that violate established standards. Architecture governance is the overarching practice of monitoring, directing, and controlling the enterprise architecture work to ensure it delivers real business value. Good governance guarantees that the organization actually builds what was designed in the architecture phases, preventing costly technical debt. It also provides a transparent system for decision-making, so everyone understands why certain technologies are approved or rejected. The exam will heavily test your knowledge of governance because it is the mechanism that keeps architecture relevant and authoritative over time. To implement effective governance, organizations use an architecture governance framework, which consists of organizational structures, processes, and control mechanisms. This framework defines exactly how compliance reviews are triggered, who signs the architecture contracts, and how exceptions are formally managed. It connects the architecture team with other corporate governance functions, such as IT governance and financial governance. On the exam, remember that architecture governance does not operate in a vacuum, but must integrate smoothly with the company's existing management structures. One of the primary tools used to enforce governance is the architecture contract, which is a formal agreement between the architecture team and the implementation teams. Created during Phase G, this contract explicitly outlines the technical standards, budget limits, and design specifications the developers must follow. It prevents scope creep and ensures that builders do not substitute approved software with unauthorized tools. Exam scenarios often highlight architecture contracts as the legalistic glue that binds the strategic design to the physical construction process. To verify that projects are following these contracts, the architecture team conducts architecture compliance reviews. A compliance review is a formal audit of a specific project to ensure its design and implementation match the approved target architecture. These reviews help catch design errors early in the development lifecycle, saving the company time and money. On your exam, remember that compliance reviews are the primary governance activity executed during Phase G to keep implementation teams on the right track. When conducting these reviews, architects evaluate projects using specific levels of architecture compliance, which measure how closely a project aligns with the rules. A project might be completely conformant, meaning it follows every rule perfectly, or it might be non-conformant, meaning it breaks the rules and requires redesign. Sometimes a project is granted a formal dispensation, which is an approved exception to break a rule due to urgent business needs. The exam often tests your ability to understand that non-conformant projects must either be fixed or receive an official dispensation from the architecture board. The timing of these compliance reviews is just as important as the reviews themselves. Reviews are not just done at the very end of a project, but are scheduled at specific checkpoints throughout the project lifecycle, such as after initial design and before final deployment. Catching a non-compliant system before it is fully built is significantly cheaper than tearing it down and rebuilding it later. Exam questions frequently check your understanding that compliance reviews are continuous, scheduled interventions rather than single events. Another key component of the capability framework is the architecture maturity model, which is used to evaluate how well the architecture practice is performing. A maturity model allows a company to score its architecture processes on a scale, typically ranging from a chaotic, informal state up to a highly optimized, continuously improving state. By assessing maturity, leaders can identify weaknesses in their architecture governance and secure funding to train their teams. On the exam, maturity models are presented as the primary tool for measuring the internal success of the architecture department itself. To improve maturity, an organization must ensure it has the right people, which is where the architecture skills framework becomes essential. The skills framework provides a standardized vocabulary for defining the roles, skill levels, and experience required for different types of enterprise architects. It helps human resources departments write accurate job descriptions and create clear career progression paths for technical staff. Exam questions often ask how organizations manage the human element of enterprise architecture, pointing directly to the implementation of the skills framework. The skills framework recognizes that enterprise architecture requires a diverse mix of technical and soft skills. An effective architect needs deep technical knowledge to understand complex systems, but they also require strong communication, negotiation, and leadership skills to manage stakeholders. Because architecture involves guiding change across an entire company, the ability to explain technical concepts to business leaders is absolutely critical. On the exam, remember that soft skills and business acumen are weighted just as heavily as technical expertise in the skills framework. Governance also plays a critical role in architecture risk management, particularly when dealing with residual risks that cannot be fully eliminated. While architects identify and mitigate risks during the admiral phases, the architecture board is responsible for formally accepting any remaining residual risks before a project proceeds. The board must look at the business benefits of a project and decide if those benefits outweigh the potential dangers of the residual risk. Exam scenarios frequently place you in situations where the board must make the final call on risk acceptance. It is vital to understand how governance interacts continuously with the architecture development method throughout the entire project lifecycle. Governance is established in the preliminary phase, secures project approvals in Phase A, monitors physical implementations in Phase G, and reviews ongoing change requests in Phase H. The Admiral provides the process for doing the daily work, while governance provides the authority to ensure the work is done correctly. The exam expects you to recognize this symbiotic relationship, where the ADM and governance rely on each other for enterprise architecture to function. A common mistake certification candidates make is assuming that IT governance and architecture governance are the exact same thing. IT governance focuses on the daily management, operations, and support of IT services, such as resetting passwords or fixing servers. Architecture governance focuses specifically on the strategic design, compliance, and evolution of the enterprise systems over time. Keeping this distinction clear will help you avoid trap answers that confuse strategic architectural design with everyday IT service management. Another area where candidates struggle is understanding dispensations during the compliance review process. Remember that a dispensation is not a permanent change to the baseline architecture, but rather a temporary waiver granted to a specific project for a specific reason. The architecture principles remain completely intact, and the project is simply allowed to bypass a rule temporarily, often with the condition that it will fix the issue later. The exam frequently tests your understanding that dispensations handle exceptions without destroying the underlying architectural rules. As we look back across the entire TOGAF standard, you can now see how all the modular pieces fit together perfectly. The Admiral provides the step-by-step process, the techniques provide the analytical tools, the content framework standardizes the documentation, the continuum organizes the reusable assets, and governance enforces the rules. When you understand how these components interact, you move beyond simple memorization and truly start thinking like a professional enterprise architect. This holistic understanding is exactly what the certification exam is designed to validate. As you prepare for your exam day, focus on the flow of information and the purpose behind each architectural activity. Do not panic if a scenario question seems long or complex. Simply identify which phase of the Admiral is being described and apply the relevant governance rules or techniques. Trust in the foundational concepts you have learned throughout this course. Take your time reading the questions carefully, and remember that every concept ultimately traces back to solving a real business problem. You now possess the comprehensive knowledge required to pass the TOGAF 10 exam and advance your architectural career. Congratulations on completing Section 6 and finishing the entire TOGAF 10 exam prep course. You have demonstrated incredible dedication to mastering enterprise architecture, and you are now fully equipped to tackle your certification exam. To lock in this final layer of governance knowledge, please complete the attached practice test right away. Practice questions are the absolute best way to improve retention, test your active recall, and guarantee your overall exam readiness. Best of luck on your certification journey. Continue actively applying these principles, and step confidently into your future as an enterprise architect.